This is the Mathematics Education Podcast from mathedpodcast.com. Welcome to the Math Ed Podcast. My name's Sam Otten. I'm coming from the University of Missouri, and with me today I have Ian Whitacre, who's an assistant professor in the School of Teacher Education at Florida State University, and I've invited him to talk about his new article in JMB's Journal of Mathematical Behavior, which is coming in Volume 31. It's entitled Happy and Sad Thoughts, An Exploration of Children's Integer Reasoning. Ian, thanks for coming.
Thanks for having me, Sam.
So I actually want to start by just asking you to go back to your dissertation, and if you could just tell us briefly about your dissertation, who advised you on that, just so we can get to know where you're coming from.
So the article belongs to a different research program from my dissertation.
Okay.
I worked with Susan Nickerson at San Diego State, and the dissertation was a study of prospective elementary teachers' number sense development. So that's something that Susan and I have worked together on for some time, and that's one of my two major research interests.
Okay. And so this study comes out of a larger NSF project, which you mentioned is separate from your dissertation work, but obviously related in the sense of number and integers and elementary level of mathematics education. So could you tell us a little bit about that larger NSF project where this study comes out of?
Well, it's about investigating how children think about integers or integer-related tasks. So there's some literature on attempts to teach integers and some documentation that students have difficulties learning integers, but not much known at all about how they reason about integers.
Okay.
So we sort of thought, let's take that as our starting point. Let's find out those who have been introduced to integers, how they think about them, and younger children who haven't yet, what ways of reasoning they bring to the learning of integers. So that's the big idea. In 2010, we did a number of exploratory interviews where we tried out different tasks and modified them. And then in 2011, we did formal data collection with 2nd, 4th, 7th, and 11th graders, where we selected and we interviewed 40 children each. And
Okay.
the paper I'm going to talk about comes from the 2010 data,
Okay.
which is more exploratory in nature. So I'm not going to make claims about representativeness of the students.
Okay.
I'm just going to say, here's what we found about their reasoning.
Right. And that makes sense as sort of the first phase of that project of really doing that exploration with the students and their integer reasoning. And so could you say a little bit more about, so from that larger project, really where this particular JMB article, how that got carved out and what was behind that decision?
It was in a very early pilot interview with a middle school student. She was talking about how she thought about integers, and she said she thought about them in terms of happy and sad thoughts. And when there's one happy thought and one sad thought, they kind of cancel each other out. And she used that in her thinking about integer arithmetic. So that's something we just kind of picked up on and said, I bet when we're talking to kids who haven't been introduced to integers formally, this is a context that would make sense to them and give us a chance to explore how they would reason about it.
Okay. So, and so you mentioned the happy and sad thoughts from the title, but that's also the central task of this article, where, there are posed to children several problems that have to do with this idea of happy thoughts and sad thoughts, and the notion that a happy thought and a sad thought, one-to-one, they neutralize each other, or they become a neutral.
Right. So the happy and sad thoughts in the title is not about what we found. It's not we found happy and sad results regarding children's reasoning. It's referring to that task.
And so could you take us through, maybe if you want to say anything else about that task, and then the participants for this particular study and the setting of it?
To present the task, we had happy and sad thoughts represented by little smiley and frowny faces.
Okay.
Those circles drawn on a paper. And we would say to children that every day Jessica has happy thoughts and she has sad thoughts. And if she has one happy thought and one sad thought, then she just feels normal. She doesn't feel happy or sad. And that's just the way it works for Jessica.
Okay.
And then we would give them numbers of happy and sad thoughts represented as these pictures of smiley and frowny faces, and then ask them what kind of day it would be. Would this be a happy day? Would it be a sad day?
Okay.
Would it be neither?
Uh-huh. And
we also asked them to compare days.
Which day was more happy, which day was more sad, and giving them different situations.
Right.
Okay. And then what, can you say a little bit more about the students that you had doing this task?
They were K through 5 students. A total of 33 students got this particular task.
Okay.
Some of the particular numbers that we used and the follow-ups varied, but they all got the basic task, and then we just sort of explored from there how they were going to reason about it.
Okay.
The kids weren't selected for special reasons. We were just going out and trying things and seeing what they might say.
Okay. When you have the data from the students working on this task, then can you take us through in the article the analysis that you did or the research question that then you were addressing from that data?
So in this context, I guess we should talk about how it relates to the integers.
Okay.
So we talk in the paper a bit formally. It's an investigation of children's integer reasoning, and we bring a mathematical lens to it, like an expert lens.
A formal mathematical lens, yeah.
So there are a lot of different ways or different lenses that you could bring. For example, another paper that we're working on, we use a history of math lens. And in others, you might just really stick with children's reasoning and do your best to describe it on its own terms.
Right.
But in this one, we're thinking about the integers, what are the properties of the integers, and how does that relate to what we see kids doing in this context.
And now you mentioned formal mathematics, and in the paper you draw a distinction between two different realms of integer reasoning. You call them realms of integer reasoning. And that's magnitudes and formalisms. So could you, again, just say a little bit more about each of those?
Right. So we've tried to figure out what we mean by integer reasoning in discussions over the last 3 years or so. We're working on a framework of what we call integer sense. And I think that'll be a product that comes out, a couple years from now.
Okay.
After we've done more analyses of our data from last year. So in terms of magnitudes and formalisms, these are two themes that come up in terms of directions involved in what it means to reason about integers. So you could start with representations, like a -5 or something, and think about what that means. And part of what it means may be just how it relates to other symbols and how it behaves
within the formal
with
system.
other numbers abstractly. And part of what it means is how it relates to the world.
Okay.
Right? And then you can also go the other direction. You can look at situations that are commonly used in integer instruction, like involving money or elevation or temperature or those sorts of things. You can reason about those situations without integers, or you can sort of superimpose the integers on them and think about it that way. So when we say magnitudes, we mean those contexts in the world or maybe in a made-up world that you could describe using integers. And then formalism, we mean the world of formal mathematics and how the integers behave there.
Okay. You mentioned in the paper about how the magnitude realm of integer reasoning is more what the students were actually doing in the task. And so in the article where there is a lot of the formal mathematics, you make clear in the article that you're bringing that formalism realm of integer reasoning as an interpretive lens, and it's not meant to represent how the students are actually thinking about it.
We say that a few times. I hope it's clear enough. And if you look at the body of work that comes from our project, this is the only paper in which we take this formal mathematical lens.
Okay.
We're kind of trying to look at the phenomenon from a variety of different angles.
I'd like to move now then into what you actually saw in terms of the students' reasoning. So when they were working on this task, what did you find for their types of reasoning or the reasoning that they engaged in with the integer task?
So in the paper I focus on 3 students, Stephen, who's a 1st grader, Chelsea, who's a 3rd grader, and Tanya, who's a 5th grader. Those are pseudonyms, of course. So I use them to exemplify these 3 ways of reasoning that we identified in the analysis. And then toward the end, we report how many kids across K through 5 reasoned in those ways.
Different,
but again, with the caveat that we're not saying too much about that.
Your goal is not really to characterize in general terms how students reason about it. It's more to explore the different ways that they reason about it.
Right. But given that we interviewed more than just those 3 kids, readers would probably be interested in how they all reasoned.
Okay.
So Stephen was in first grade, and he was very entertaining kid to listen to, very sort of spastic.
Uh-huh.
But when he was comparing, so looking at a particular day first, he could tell whether it was happy or sad correctly.
Okay.
So if there were 2 happy thoughts and 7 sad thoughts, he would say it was a sad day, and he would point out that there were more sads.
Mm-hmm.
He wouldn't necessarily even count,
right?
Because he was just trying to find out if it was happy or sad, and that was based on which one was more.
And he has the visual representation in front of him on the test. And now, was that visual representation stacked, or were the faces lined up?
Typically, it was just horizontal.
Okay.
Unless there were so many that it didn't fit.
Okay.
Aligned horizontally.
Okay.
So that was Stephen, and something interesting that came up right away. I remember he was first given kind of a gentle introduction with the younger kids.
Mm-hmm.
He was given like 1 happy and 0 sad. What kind of day would that be?
Uh-huh.
And he said it would be happy and 0 happy and 1 sad. And he objected that these tasks were way too easy. And then 1 happy and 1 sad. And he hadn't been told yet what Jessica's experience is like. That when she had 1 happy thought and 1 sad thought, she would just feel normal.
Mm-hmm.
So we would sort of see what kids would say about that first,
okay,
and then follow up and say, well, this is what it's like for Jessica.
Okay.
To clarify that if necessary. So when he saw the 1 happy and 1 sad, he said it would be a happy and sad day.
Okay.
Or you would feel confused, is another way he described it.
Okay.
You're not sure if you're happy or sad.
Right.
And that's something he carried over to other numbers. If they were equal numbers of happy and sad thoughts, he called it a happy and sad day or confused day.
Okay.
So that's Stephen. Now, when it came to comparing days, he didn't do what you might expect, which would be to say, well, this is a sad day because it had more sads, and that's a sad day because it had more sads. So they're the same. They're just both sad.
Mm-hmm.
He didn't sort of use the product of how he analyzed the days initially to compare. He looked at the 2 days, and if you asked him which was more sad, he would just compare the sad thoughts belonging to those 2 days.
Okay.
And not take the happy thoughts into account.
So, right. So his attention was focused. If it was a sad day, his attention was focused only on the sad, frowny faces.
Right.
Okay.
Or if whatever you asked him to attend to.
Okay.
Which day was happier, he would compare the happies.
Okay.
So that's where Stephen's reasoning was a lot different.
Okay.
From the older students, is that there's no attempt to coordinate. Now you have 4 different numbers of thoughts you're dealing with and comparing.
Right.
You have happy, sad, and
how are you going to manage?
He would deal with 2 of those sets at a time.
Okay. So you're already kind of alluding now to some of the older students. So Chelsea, you mentioned, was a 3rd grade student, and so it sounds like she is going to do something a little bit differently than Stephen.
Mm-hmm. Yeah, I guess I was hinting at what Chelsea would do. So Chelsea, let's talk about the same day. Given 2 happy and 7 sad thoughts, she just spontaneously used this crossing out kind of procedure. She circled 2 of the sads and said those would cancel with the 2 happies, and she crossed those out and said, well, there's 5 sads left, so it would be a sad day, and specifically she recorded that as 5 sads.
Okay. And she was she prompted to write that down, or she just on her own wrote down that 5, or she remembered that as a 5?
Don't recall exactly.
Okay,
it may have been that she was asked how sad it was, or it may have been that she didn't start recording 5 sads until she was asked to compare days.
Okay. And so in the comparison now, so if she has for this day, like you were using the example, 2 happies, 7 sads, which she now has this idea of 5 sads sort of left over after her sort of neutralizing or normalizing those ones that pair up. So then how did she coordinate that when she was now comparing different days?
Right. Well, so in her case, it pretty well follows from how she looked at the days individually. If this is a 5 sads day and that's a 4 sads day, then clearly the 5 sads day is more sad. so she didn't have that coordination issue that
She set herself
that
up to
Stephen
already
did.
be able to make
She
that.
just had these two numbers to compare now. So she took the number of happy and sad thoughts in a day and resolved it to a single value.
Okay.
And then she used those to compare.
Okay. So now what's left for Tanya then in 5th grade? So Chelsea sounds like she's made it pretty far.
Right.
So now what's Tanya doing?
Yeah, it's not a big jump
Okay.
from Chelsea's reasoning to Tanya's. The difference is just that Tanya recognizes this as being about integers. She spontaneously thought this context had something to do with positive and negative numbers. So she did the same sort of computing a net value for each day, only for her this was about adding positive and negative numbers. So,
Okay, so she brought this machinery of actually numerals and negative numbers symbolically. She brought that to the task.
So for the same day we're talking about, she would say that's positive 2 and negative 7, and then the sum is negative 5. So instead of writing 5 sads, she would write negative 5 for that day.
Okay. Now, as a 5th grader, so this is obviously, it's coming into play that she's had some instruction, in classrooms probably. And
Yeah.
she's... Okay.
I don't think it came from independent research.
Right. Well, and I'm just curious, too, because about now... So I guess you would say that the task wasn't presented as an integer task. She brought that language of
She
integer.
wasn't
She just
asked-
recognized it in the situation.
Yeah, she wasn't asked to use integers or anything like that. It was just something about the context led her to say, this involves positive and negative numbers.
And then, so just to remind listeners that, we're talking about these 3 individual students, but you in the article chose these to represent actually, groups of students that you saw this common way of reasoning about the numbers.
Right.
So they're representative of a class of students that are reasoning that way. So a question I had, so you described the way that the student made judgments about the day, but then you also described the way that students compared one day to another day. From your description, we could kind of almost assume that, those go together. Now, would you say that those do tend to go together, or are they independent? What are your thoughts on the interaction between those dimensions of the judgment and the comparison?
Well, what we found empirically was that in every case they did go together.
Okay.
So kids who reasoned like Stephen about individual days reasoned like Stephen in comparing days, and likewise for Chelsea and Tanya. Like I started to say before, for Chelsea and Tanya, the comparison pretty well follows from how they look at an individual day. Once you have that net value that you get out of it, it's obvious how to compare. Whereas with Stevens, he doesn't really take his way of looking at an individual day and carry it over in the way that you might expect. Instead, for individual days, he compares 2 sets, and in looking across days, he compares 2 sets. And the 2 sets he compares are different, sort of going along with the task. So that's the connection I would point to.
Okay. Now, we've talked a lot about this happy and sad thought task, and I do want to point out that in the article, you make clear that you're not intending this task to be a model lesson, or you're not saying teachers need to start using this. You were using it as just a venue for exploring the students' reasoning.
Right. Yeah, it's extremely unrealistic to suppose that happy and sad thoughts behave additively and that they're of equal weight.
Right.
There aren't bigger or smaller,
right.
Emotional values associated with them. A point we make in the paper is we didn't insist on an additive interpretation. It was sort of left open. So you could say, if all you know is for Jessica, if she has one happy thought and one sad thought, she feels normal. That could be about the difference, or it could be about the ratio between the numbers of happy and sad thoughts. And I think if you ask people about their experience, maybe the ratio would be a more fitting measure. I don't know. But we just sort of left it up to students to see how they would interpret it. And 30 of the 33 that we talked to used this additive interpretation.
Okay.
They kind of assumed that what they were told about Jessica meant that that they should compare additively.
Right.
Or that's what they brought to it. That was their way of comparing the numbers of thoughts.
Right.
We don't suppose that happy and sad thoughts behave that way. And I really hadn't thought about this at all as a context that you would use to teach. It was something that's accessible to little kids.
Right.
They know what happy and sad mean. Those are opposites. And it was natural and it was easy and accessible for them to think about this, as opposed to going in and having to say, here's a game we're going to play and these are the rules of the game, and having to teach them something. This was just a quick prompt and you're off and finding out how they think about it.
Speaking of teaching and tasks that might be used in practice for working with students on integers and integer reasoning, so a fairly famous one is a bus situation, and that comes up in the article, which is the idea that you have students attend to the total number of people on a bus, but they can't necessarily always look in the bus or count. But what the students do see is that at points in time, people will exit the bus and other people will enter the bus, and then now the new question is, okay, now how many people are on the bus? And this is also used to approach integers, and you bring it up in the article, but I just wanted to ask in terms of what you see similarities between your happy and sad thoughts task, similarities between that and the bus task, or differences between happy and sad thoughts and the bus task.
In the discussion toward the end of the paper, we kind of say, these are ways of reasoning that we found, and they're probably not unique to this one context.
Right.
So we can imagine other contexts that involve what we call opposite magnitudes in the paper, stuff like happy and sad, or in the case of the bus task, actions that cancel each other out. And we imagine that we might see the same kinds of ways of reasoning in those contexts as well. It's obviously an open question. And there are differences in the properties of different contexts that you might use or see as related to integers. The mapping between the context and integer addition is different. So it's not that I think those contexts are the same, but I can imagine each of the children that we talked about reasoning in similar ways about them.
Within that bus context. And it would be interesting to see if they did reason in similar ways, because like you mentioned, there's an action that's canceling in the bus situation. People coming on is an action and people going off is an action, and those actions can cancel each other out or sort of balance each other out, which to me connects more with operations, like the operation of addition or the operation of subtraction. Whereas happy and sad thoughts, it's, they're presented as objects. There's this face that's a happy face and this face that's a sad face. And those objects neutralize each other, which to me is more like representative of positive and negative numbers rather than the operation of addition and subtraction. So it would, we can imagine Stephen and Chelsea and Tanya reasoning in that bus situation in maybe some of the same ways. But to me that is also significant if they were reasoning in similar ways, because it is now applying it to actions instead of to objects in the same way.
Yeah, that's a good point. It's an insightful observation. One thing about contexts like that, when they're used in instruction or when they appear in textbooks, is that there may be a prescribed way that students are supposed to represent. So you talked about as addition and subtraction, but I would expect in a textbook that was using that to teach about integer arithmetic that would be represented as adding positives or adding negatives.
Right.
Which is interesting to think about. It's probably not the most intuitive.
Right, because, students would have been coming from the early grades of having a pile of chips and actually pulling chips off, which is very analogous to people exiting a bus. But now, there's the opportunity to make the connection between subtracting positive numbers and adding negative numbers, but there's also the possibility for confusion, because they might say, well, naturally, I want to call that subtracting.
Right.
And now you're telling me to call it something different. So there's the possibility for connection, but also there might be the possibility for confusing or confounding the students.
I would say the probability.
So you've talked to us about the students in this individual article and those three ways of reasoning about integers. But I was wondering if you have sort of one main idea or one takeaway point that you'd like the listeners to have from this study.
Well, a point that we try to make in the paper is that we call out two formal properties of the integers with addition, which are the fact that you have inverses and that there are equivalence classes.
Okay.
Those are sort of how we frame it mathematically. And then in discussing the children's reasoning, we identify ways in which they reason about happy and sad thoughts as integers, and they recognize equivalence classes of these days, or these groups of happy and sad thoughts. So in that sense, it's recognizing children's ways of reasoning that relate to rather sophisticated abstract algebra ideas. even Stephen recognizes equivalence classes when the numbers of happy and sad thoughts are the same.
Mm-hmm.
So that specific equivalence class of confused or happy sad days was something that resonated for him and that stood out as special. That's the only equivalence class he recognized, whereas Chelsea and Tanya recognized many. There's really no limit to the number that they would. So part of it is making those connections to say, look at these, when framed this way, when looked at through this lens, these rather sophisticated ways of reasoning that we see in these children, in the case of Stephen and Chelsea, pre-integer instruction.
Mm-hmm.
And that thinking of it in terms of the larger study, for me is the major takeaway, is that kids are smart. They can figure things out given the chance. Mm-hmm. We've seen a lot of instances in the K through 4 students that we've interviewed of productive resources that they bring, ways of figuring out how integer arithmetic could work or they think it should work, although they haven't been taught to do it. Mm-hmm. And in our interviews with middle school students, we've seen a lot of misremembering of rules and doing things that don't make a lot of sense.
Right.
So where the larger study points to for me is that children can figure these things out and build on what they already know.
Right.
And that's a message. I don't know how well it comes across in the article, but I hope that it's one message of the article.
And of the larger body of work as well. And so you happen to be working on some more work related to this, and so I want to give you a chance, too, to talk about some things that you've done since writing this study.
Well, we've been analyzing other tasks. We have a lot of data. We coded all the data, but there's still the question of extracting useful information from that, tabulating all your coding and things. So it's sort of been task by task.
Okay.
So I presented at PMENA about another particular task that we've used, and drawing from the 2011 data on that, and I focused on 7th graders in that one, and I won't go into it.
Right.
But
maybe for another episode.
We're continuing to analyze and learn different things about children's reasoning. And then moving forward, what I'm interested in ultimately is the question everybody wants to know, how can we design instruction? Mm-hmm.
That really takes advantage of those strengths that students bring that you just mentioned earlier.
That's the idea. Yeah. So I'm planning for next year a very small-scale teaching experiment with just a few kids. I'm thinking like 4 to 6 kids in about 3rd grade, where that's the idea, is to start where they are and find out how they can build on what they know to start to reinvent at least some of integer arithmetic. Mm-hmm.
So I'm speaking with Ian Whitacre from Florida State University. We're talking about the study that's coming in JMB Volume 31. I also want to give you a chance to mention your co-authors, and I know there are quite a few of them. So I have them here, actually, if you want to, but I want to make sure that we acknowledge them as well.
Right. Jessica Pearson Bishop, who's now at UGA, was the second author on the paper, and she's a co-PI on the DRK-12 grant. Okay. Lisa Lamb is the PI. She's at San Diego State. Randy Phillip is also a co-PI at San Diego State. And Bonnie Chappelle and Mindy Lewis also worked on the project.
All right. Great. So Ian Whitacre's been my guest, but I want to ask him one more question before I let him go, and this is not related to math education, but I'm just curious, and just so the listeners can get to know you a little bit better, what would you be doing if you weren't in math education? Weren't teaching math, weren't researching math, what would you like to see yourself doing?
Well, last year, PMENA was held in Reno, Nevada.
Right.
And the time I didn't spend at the conference, I spent playing poker.
Oh, really?
I did quite a bit of that online for a while, too. So there's a strong possibility that if I was no way involved in math education, I would at least take a shot at being a professional poker player.
Oh, wow. Well, people will keep that in mind if Ian tries to hustle you at a future conference. Thank you, Ian Whitacre, for talking about your article. MathEdPodcast.com will have a link to the article and have that reference. So thank you very much.
Thank you.